So this is the most awaited session. This track is dedicated for Android sessions throughout the day. And we, in the true Google style, we'll be doing this Android session over a Hangout. Okay, and there are two gentlemen who are joining us. We have got Aniruddh joining from the Hyderabad office. Aniruddh,
Hi everyone.
And we have got Tony Chan joining us all the way from Hong Kong. Hi, Tony.
Hi everyone.
And they are developer advocates for Android. And the format is going to be pretty simple. We'll be having two back-to-back sessions. We'll be having a 45-minute sessions, and there won't be any kind of interruptions in terms of Q&A. There'll be a lot of ushers out here in wearing red T-shirts. Okay, and they'll be having slips. Collect the slips, fill in your questions, and they'll be able to pass it across to me, and I'll be moderating it. Okay, so at the end of 45 minutes, you'll have a Q&A for around 10 to 15 minutes, and we'll take a 10 minutes break, and we'll have the next session, which will be on UI and UX. Okay, sounds good? Okay, so let's get going. Over to you guys.
Okay. Hi everyone. Welcome to Chile, India, at Mumbai. So I'm Aniruddh, and Tony, you already about Tony. So we are part of Android developer relations team at Google, and we work with developers just like you. So first of all, I would like to apologize that we couldn't be there, and we would love to be there next time. So hopefully when we have a section next time, we will physically be present there. So let's get started with the presentation here. The topic for today's first talk is what's new in Android. And this is from Jelly Bean perspective, which we just launched. So we're going to talk about some of the motivations behind the work we did, and some of the new UI stuff, and some of the new features available to you guys as a Jelly Bean developer. So the first thing I would like to talk about is Project Butter. So Android has been there for a long time, and we noticed that there was a lot of scope for improvement in making the UI consistent, making the UI very smooth and fluid. And so this is a project that we undertook, and we call it Project Butter, so smooth and slippery as a butter. This was one of the main goals of the iteration. So first of all, what Project Butter means, it means having a consistent fluid UI, no choppy frames or jank, what we like to call jank. So we'll just define jank here. Jank means you have missed frames. For example, if you're sliding your slide gesture, you're moving from one screen to home screen, and there are transitions. Sometimes frames are missed, and this results in very choppy and jittery animation. And you notice this as a user. Sometimes the same frame is repeated on the buffer, and you see two frames. For two frames, you see the same snapshot because we couldn't update the display buffer in time. And this is again jank. So this was what we started out to eliminate with the Project Butter. Next slide. Yeah. So one of the key components to help us drive this was the VSync. VSync, if you're familiar with display terminology, is it's a control signal. What it can do is it can synchronize. We decided to synchronize all the operations that happen in the Android, including the system operations, including the I/O events, including CPU, GPU, and all these operations. We sync them to VSync, to this control signal. So it is generated per frame. For example, for Nexus 7, the display draw is at 60 frames per second. So the control signal is generated every 16 milliseconds, and at every 16 milliseconds, we start the GPU, CPU work. CPU work is your code running. GPU is the work that once you in your code, you decide to put up some list or create some UI, you have these commands to draw on the screen. So the GPU will take up this draw commands, whatever you send it for draw. So all this work needs to be done within the 16 millisecond frame, and once you achieve that and synchronized, you will notice that it's much more smooth and much more jitter-free. And this is what is jank, eliminating jank and Project Butter all about. So first of all, let's see what it is drawing without sync. So as you can see, I'll just tell you what's in the diagram first, and then I'll start explaining you. On the top, there's a yellow bar. a yellow list, and you see numbers on it. So there's 0, 1, 1, 2, 3. This is the frame that is being displayed on screen every 16 milliseconds. So I would just like to tell you that we've always had vsync, but we were not synchronizing all the operations in the system to it. But vsync was always there at every 16 milliseconds. It's just that CPU and GPU were not synchronized. So this is the scenario, how it used to happen when CPU and GPU were not synchronized. So the yellow bar on top is the frame number, and you see the first is the blue box. Those blue boxes are CPU time, which is your code running. So we start at every frame, we start processing your code. Your code runs on the CPU threads. That's the time taken in the blue box. And once your CPU is done, work is done, and you have your display commands ready, GPU takes over and does the GPU, the graphic rendering work, and that's the green box that you see. And at the end of the control signal vsync, we would display the next buffer comes into picture. So we've already done all our work, so we are ready with the next frame and we display that. Now, because CPU and GPU were not synced, you see the second blue box, number 2, that starts off late. It's not synchronized with control signals, it starts off late. By the time it's done and it hands over work to GPU, and by the time that finishes, we've missed the display refresh. Every screen has a property of display refresh, which is the frequency at hertz. So we missed the frame. So the same, because we are still doing GPU work, our next frame to draw is not ready. So the same frame, frame number 1, is repeated. And this is, you see the same frame being repeated over and over again, it happens. And this is called as jank. And so this was what was happening without vsync. Next. So let's see how this will be very clear with you what the vsync synchronization does for us. If you can see now the blue boxes of CPU, the first box is the first frame CPU work, the GPU work starts, we are done, we refresh the frame to the first frame. Just when the first frame is displayed on the screen, we've swapped the buffer and the new frame comes into picture. At that same control signal, we start the CPU work again. So you can see the vertical bar aligning with the CPU. At the very same time, we again kick off CPU work for the next frame. So in this case, the GPU happens to take a lot more time. Maybe you have very intensive draw operations. It takes a lot more time, but then because we synchronize it to the signal, we are still able to complete it to refresh to frame 2, and so on for 3 and 4. So this eliminates repeated frames, and this is what vsync does for us. So another improvement that we did was triple buffering. Before I tell you about triple buffering, let's see what the scenario was with double buffering. So double buffering means that we keep 2 frames or 2 buffers with us, and so while something is being displayed on screen, we have another buffer where we put the next screen that is supposed to go, and then we swap the buffer on the screen. And then we take the one that is swapped out, we draw the operations on this one, and then we again swap it back to screen and take out that. So those are the AA, BB, A that you see. Those are the buffer or memory areas that we have where we can do our CPU work. So if you look at the diagram there, we start off, while A is being displayed on screen, we start working on B for CPU. We do the operations, we do the GPU operations, and because the GPU operations went for a long time, buffer B was not ready, so we still displayed A on the screen, and because of which there is a jank. And now because we display B, when we swap out A, it's already the time that B is finished. We don't even have A ready to us. So if you see the GPU, it finishes the work at B after the control signal, but because A is still on screen, we can't use it to draw the next frame. So we wait for the next control signal so that A can be freed up and we can start operations. So this leads to some of the frames that are repeated, and the CPU and GPU are sitting empty and they cannot work on the next frame because there are only 2 buffers and they cannot work on the next buffer. So with Jelly Bean, again, we introduced triple buffering. With triple buffering, now you can see there are 3 frames, A, B, C. So while A is being displayed, we are working on B. And for some reason, if GPU takes a lot more time because it's a very intensive screen, we miss displaying B on the screen, so there is still some junk. But then, as soon as B is done with the GPU, we can take up C and start doing the third frame. So we have 3 buffers now to work. So we don't have to wait for A to be emptied from the screen so that we can start using it. So while A is being displayed and B is ready to be displayed, we have C to work on the next operation. And over a period of time, you will notice that these 3 buffers improves the system efficiency a lot when it comes to rendering. And this is what triple buffering is, and it's helped us with Jelly Bean. Another change that we did was with the input latency. We wanted to reduce the latency of events that are dispatched. What is latency is if you hold the phone and you try to drag some icon, so there is a touch gesture which is your input event, and then there is a response on the screen, and the time that it takes to take your input into effect is the latency. So if you're dragging something, you might notice that if you're dragging an icon, it's kind of left behind because it's still catching up on your input, and this is the latency of input. So how it used to happen pre-Jelly Bean is we have this green strip on the top, A to X. These are the series of input events that are constantly generated from the screen. So if you're dragging or you're doing swipe or any of those gestures, these inputs are being fed into the system continuously. And we had this component called dispatcher. So what dispatcher would do is it would run at regular intervals. It would take up all the events that have happened till that point of time. So if you look at the dispatcher, which is the blue box, when it starts, it picks up all the events that are there in the queue, which is A to C. It picks up all those and it sends it to the processor, and it goes through the draw cycle. So it goes to activity, which is your code, which is the CPU code, and then it goes to draw, and then it finally appears on screen. And after some time, we pick up the next batch of events, D to J, and we again send it back to the activity, goes through your CPU, goes through the GPU, and then comes on the screen. So if you look at the latency chart below, which is the red bars, you see the first event A, the user is not able to see the response of that until the first draw cycle is finished. And that is mid across the screen. So there's a lot of latency in when the first event was generated and when the user was actually able to see something on the screen after the draw. And it's bad for C. D is really bad because we missed that event in the first batch, and it takes a long time for it to catch up to that event and finish the draw cycle. So these bars are the latency that you would have experienced or was present in the older systems, the older versions of Android. So we set out to improve this thing, and how we did that was we got rid of the dispatcher. There is no more dispatcher now. So again, it's the same thing. You see there is a user input, these series of events that are happening, and there's a control signal, which is the vsync. For Nexus 7, it would be a 16 millisecond time frame. So every 16 milliseconds, we are directly picking up all the events that have happened. We are feeding them right to the CPU and through the GPU cycle. So A to G are fed to the first CPU cycle and the draw cycle, GPU cycle, and when the next draw cycle is ready, which is at the vsync, if you remember from the first diagram, at vsync we start the CPU operation. So you see the next event, batch of events being sent to the activity. Now, if you look at the latency, A was finished probably around the same time that you saw in the previous diagram, but there is much more efficiency with B because we were able to pick it up and it didn't have to wait for the next batch. So in general, this improves the latency of the system a lot, and it makes it more responsive. And this is one of the implementations in JB that will help you, makes the project better successful.
Yeah, so the next topic we want to cover is rich notifications. So notification is always a strength in Android, and in Jelly Bean we make it even better. So in Jelly Bean we introduced something called rich notifications, and here is a screenshot. And as you can see, for notification now you can design notifications with more unit. What we call unit is in the past, one notification, it can only take up 64 dp, and we introduced something called expandable notification, which is user can use a gesture to expand a particular notification using what we call the big content view. In this case, user can expand a regular notification up to 4 units, which is 256 dp. Another nice things we introduce in rich notification is priority. So now you can signal to the system what kind of priority you want your notification to display. Here are some examples of rich notifications. And one thing about notification is we put actions, what we call action buttons, into become first-class citizen of notification. In the past, you can still achieve action button through a custom view, but now we make it part of the framework. So here's some example of how to use the action button. One example is in Gmail. You can have a button to start composing an email and launch to a particular composed screen. Another example is having a callback button when you miss when a user miss someone call or send an SMS message. The last example here is you can have buttons to show to add +1 or we share a G+ post. Some good news about notification is we always introduce a design guideline back in early January this year, and but we don't have any new icon guidelines for rich notification. So everything we talk about in terms of icons used in notifications stay the same. So one good news for users, but probably less good news for developer is now user in Jelly Bean will have the ability to permanently disable notification of a particular app. In some way, it's also good news for developer because it gives you more incentive to do the right thing in terms of like doing proper notifications. And finally, rich notification is now part of the support library. So so this is not just a Jelly Bean feature, and then it will be available for things like in Jelly Bean, in Gingerbread, and in other version of Android. Aniruddh is going to talk about SDK tools.
Right. So there's a lot that's happening in SDK tool world also, and this is very important for all the developers. So first of all, we've got emulator now has x86 virtualization, and we've got a 2.3 and 4.0 image. So because of the x86 virtualization, it runs much faster on your x86 machines. We've also got GPU support for emulator, and the image is 4.0.3 plus onwards, and this basically provides a bridge between your emulator image and the host OS, and which speeds up, which then allows you to use the host infrastructure or host GPU for hardware accelerating the commands, and makes your system emulator much more smooth and much faster. We've also got sensor and multi-touch support, and so you can connect physical devices and use them to send sensor input and touch events to the emulator where your app is running. As far as developer productivity goes, we've got new tools like Lint. Lint is a warning and a check style kind of system. This will actually help you find out errors in your code or things that you may be doing wrong. This will help you figure out if you need to improve externalized strings or yeah, stuff like that. That will help your code much more, optimize your code and make it much more efficient. Then we've got the device monitor and system trace. System trace is actually a pretty good tool that was introduced recently. System trace allows you to capture a lot of traces of what's happening with Surface Flinger, what's happening with your app and binder, and all that time that is being spent by the system in all of these modules, and you can select what do you want to trace. Do you want to take a GPU trace or take window traces and stuff like that? This is actually a script that lives in your tools folder, and you can run the script to generate an HTML5 file, which is a report, and which you can easily navigate or you use using the HTML5 browser. For all the NDK developers that write native code, we've got debug support for NDK. So if you're writing C code or you have games and you're writing optimizing them with native code, you have now debugging support available with that. Uh, we also introduced improved our layout editor. So there are multiple device configurations that are available to you now. So you can choose what kind of device would you like your emulator or would you like your layout to behave with. So you can choose 7-inch portrait, 7-inch Nexus 7, or Galaxy Nexus portrait landscape configurations, and you can actually see the output of multiple configurations simultaneously. So you can basically, if you make a change, and the UI will show you all the different configurations that you have, and will show you how your change reflects in all these configurations, so you can spot out problems very easily and fix your code. Uh, and very exciting, this we've got app templates now, and this is just a start, and there'll be a lot more to it. What app template does is gives you a wizard kind of operation where you can to create a project where you can specify what kind of app are you creating. So you can if you're writing a tablet app and a phone app, you can choose a fragment based multi-pane layout, and you can specify this first fragment to be a list fragment and the second one to be a detailed fragment, and these templates are available. So you just click your way through and it will generate the entire step of the application for you. We've also integrated Asset Studio, so you can pick your icons right there from the wizard. And we've planned a lot more for app templates, and you will see that coming in soon.
Yeah, so the next topic is building Android application using web APIs. So we understand application a lot of time we need to have data coming from server or from the cloud. So we make this really easy. Back in Google I/O, we introduced something called Google Cloud Endpoints, and what that really is we make it very simple for developer to create a REST-based API on Google App Engines. So what you need to do is define like certain entities in on App Engines and do the proper annotation, and immediately you will get a RESTful API very easy through the Cloud Endpoint service. Another thing that is coming up very soon is what we call Google Play services. If you have done any OAuth 2 or OAuth implementation, I think most developer will know and agree that's not an easy job. And so we want to make it really simple for developer, and that what we are going to include in the Google Play service. So with this service, it's very easy for developer to get access using OAuth to talk to different Google APIs. And another thing comes with Google Play service very soon will be there will be a Google Plus API. So stay tuned for that. About Google Cloud Messaging. So this is really a rebrand of what we used to call C2DM, Cloud to Device Messaging. Again, exciting thing about this is it's free, and now it comes with unlimited quota. And also in the past, if you want to reach to all the devices, you have to send a request to one request to a particular device, and but now we make it very simple. We now support multicasting, so you can send up to 1,000 message per request to all the Android devices. And another new thing in Google Cloud Messaging is we now support a payload up to 4 kilobyte data.
Right. So apart from Project Butter and the changes to GCM, Google Cloud Messaging, and some of the things we talked about, layout editor and tools, we've also got some more things with Jelly Bean. Uh, One is activity animations. Now, this allows you to actually center your animation of an activity, which around a touch point or where you try to trigger it, and you can zoom out or zoom in based or fade in, fade out from that point on the screen. So these are highly customized animations that can happen response to and are kind of context sensitive to where they begin. Uh, then we also have widgets that can respond to automatically respond to size changes that may happen on your home screen. Uh, we've got multiple improvements in text view and how it behaves, and we've also simplified backstack navigation. We already have the concept of the idea of up navigation, and we simplified back navigation using the soft back button or the hardware back button if your phone has it. And this will basically to create a smooth flow for the user using their structural and temporal memory to intuitively lead them to something in the stack that they used before. And so this is kind of simplified now. In terms of accessibility and data, uh, we have a new permission, and this is for the benefit of all the users of Android. We've got a permission now, which is the read external storage permission, which means that if your app needs to access something from external storage, is the SD card, you need to use this permission. This is not enforced right now, but we recommend that you implement it as soon as possible in your apps. So it's not kind of forced right now, but please go ahead and update your apps to include this permission if you are reading or writing or doing anything with the SD card. Also with Android Beam, which you guys may be familiar, is our NFC Bluetooth is our NFC technology, NFC based technology, which allows you to bring two phones closer to each other, and using the NFC chips and antennas present, they can talk to each other. And this was possible for small amounts of data, which is kind of what NFC was meant for. But with we can trigger NFC and couple that with Bluetooth to actually now transfer larger files across two devices. So this is something new.
And finally, so as most of you already know, we introduced Jelly Bean in Google I/O, and I'm pleased to inform you guys like most of the Google managed device are now got the OTA for Jelly Bean. So there are Nexus 7, Galaxy Nexus, Nexus S, and the Motorola soon. Another good news is the Jelly Bean is already open source. So so feel free to go to the AOSP website to check it out. And the Nexus 7, this is the image of the Nexus 7, and is currently available in the US, I think UK, and then a few other countries. And we hope to make it available in more countries soon. And so please stay tuned. So in terms of developing for the Nexus 7, so there are some tips we want to share with you guys. So one thing is we introduced recently a new resource qualifier called the shortest width DP. And so one thing you can use to identify the 7-inch tablet is the qualifier SW600DP. So so to select a handset, you can just use the regular resource folder /layout, and for the layout for the 7-inch tablets, you can add the qualifier SW600DP. What that really means is as long as a device with the shortest width of the side with the minimum of 600 dp, it will fall into the SW600 bucket. So for larger devices like the 10 inches device, we recommend that you use the SW720 dp bucket. So finally, so this is our website. on Google Plus is the Plus Android developers page, and so we constantly update content on this this page, and as you can see in the screenshots, like, well, we also announce our regular office hours. So we have office hours in the US, and as well as we now have office hours in APAC. It happens every Thursday, 11:30 a.m. IST time, and we also rebranded. The new name is called Android Developer Lab Plus, and the format is kind of like we first introduced like some news, like what's going on in the Android ecosystem for that week, and then we will present a special topics, which we highly encourage, recommend developer to give us feedback of what kind of things you would like to hear. You can drop us a Google Plus post and recommend stuff you want to listen from us, and finally you can post your questions to moderator ahead of time. We usually post out the link a few days or a week before, so you can post questions and we can answer that live for you during the Lab Plus. So
available on YouTube later. So if you happen to miss one, you can catch up on them. And there are some dedicated sessions. For example, there was a recent session about media low-level APIs. So if you guys are working on media, you can go to YouTube or our Android Developer Plus page, and the videos posted about those sessions. All the sessions are posted there. You can catch up on any session that you would like and you probably have missed. So there's great content that's coming in every week. There are, I would say, well, I don't know the exact number, but maybe like 5 to 6 shows every week. So you have a lot of new content if you want to learn more, or if you want to ask questions and check back on how they replied, or look at some of those specialized topics. There's a lot of content that's being generated daily. So please go ahead and read there. And if you have any questions, you can join the Asia Friendly hours for Android developer.
So Aniruddh, do you have time for some questions now before we break up?
Yeah, sure. Let's go on.
Okay, so as we are not yet collected the chits, if you got question, why don't you just come out here and ask your questions?
My question is that what is the problem with the GPU when app create the jerk problem on the API?
All right, so I'll repeat and you let me know if I got it right.
Yeah.
So your question is, what's the problem with GPU?
Yeah. When the application create the jerk on the vSync technology, as you told on the vSync in the vSync slide.
Right. Right. So there are these sequence of operations, right? So first of all, the application goes through the process of rendering is that first we go through the CPU code, which is the code you have written in your onDraw command. And in your onDraw command, you may be doing some processing, like fetching some network data, and that will take some time. And then you generate, list view dot add something. So you generate some display commands.
Yeah.
Then the GPU comes in picture, and it tries to take all the commands that you've generated and tries to draw the display operations. And then the buffer is ready and it's swapped to the screen. So even with vSync, we are not saying that it's completely jank free. If you have written bad code, or there are a lot of stuff that you've done with the UI in your onDraw, GPU may still take time and miss the buffer, miss the vSync control signal. This can happen, but the overall fluidity and the overall continuity of the UI will improve, because everything is triggered right when it should, and you still got 16 milliseconds of time to finish CPU and GPU. So if you write kind of efficient code, you write decent code, it's very likely that you will have very fluid UIs, because the system kind of enables that. But jank can still happen if you have bad code.
Okay. Yeah. Thanks.
yeah, so So just back to the diagram here, right? So you see in the frame 1, so if the GPU, the box in green, still spend more than 60 milliseconds, frame 1 will repeat again. So I think so that's what Aniruddh is trying to say. Like it really depends on how efficient the code as well, and but the chance of getting repeated frames is much lower because now the CPU work is in sync with the VSync signal.
Okay, the next question is, what is the impact of third-party push services on modern Android devices, especially the battery life?
That's right. So the question is, how does third-party push services, I believe one of them is Urban Airship, and stuff, how they impact battery life? Uh, well, uh, without picking any specific name, some of the third-party services actually send you spam ads and stuff like that. So and the Google Cloud Messaging service is meant for delivery of for real-time notifications, so that push messages, so that your app can wake up and pull data from the server when it becomes available. So it's always gonna it's a thing that can wake up your system, all right. But if as a developer you are careful about what kind of notifications you're pushing onto the system, it's all right. But I cannot comment on third party because I've not used any of those. Maybe if Tony has some idea about them.
Well, I guess like third party, are they referring to carrier or developers, right?
I think like third party frameworks like parallel to GCM that can be used across multiple mobile platforms to push
Oh,
messages.
yeah, I don't know.
It's hard to say.
I think it's hard to say. We can't speak for other implementation, but the cloud to device. I mean, the Google Cloud Messaging is a push technology, and is we have battery life. Is one of the top priority in our design. So so if you choose to use Google Cloud Messaging, so you will be ensure like the Google engineers will treat battery life as top priority, I guess.
Right, and because it's using similar infrastructure that other services, Google services use, the Gmail, the Talk and stuff, so kind of some of the operations are batched together, and that helps you don't wake up the radio very often, because most of the sync operations and system operations in GCM, they're kind of batched together. So you make this one time when you wake up the system and perform the operations, rather than waking up the system, every now and then. So that's one optimization you get.
Yeah, one tip we want to share with developer is for in terms of fetching data is always better off to fetch large ton of data less frequent compared to you fetch small chunk of data very frequently, because you really want to allow the Android device to go to something we call the sleep mode to save battery. I mean, if you constantly fetching data, the phone will not have the chance to go to the battery safe mode. So that's one advice, pro tip we want to share with you.
And next question is, what's the minimum processor requirement to run Jelly Bean to avoid lagging?
We actually do not have any published numbers like that. So Jelly Bean uses 3D for 3D rendering. It uses your hardware acceleration. So it's not just the CPU clock. There's a lot more in the complete chipset. There is the GPU and stuff. So there is no. Yeah, I mean, one of the things that happened was with Nexus S device, right? It was running ICS, and actually when we shipped Jelly Bean on it, it became much faster with Jelly Bean. So we were actually able to run Jelly Bean faster on an older processor compared to the previous version. So it's actually much more improved and much more efficient, but we do not have any number like that, like you need this much hertz processor to do this. Yeah, sorry.
Okay. I think that's all the questions for now. There are a lot of pretty generic questions which we'll be able to take it offline. There'll be a lot of Google engineers who will be able to take questions regarding your Nexus release and so on and so forth, and why we are not doing it. It's just we are doing it earlier on in US, and it's just a matter of time, and we'll be making the announcements. What do you see in terms of announcements which has been made on the site? That's pretty much updated. And the minute we are thinking of launching, everyone will come to know, including me, on the same day. Okay? So with that, a huge round of applause to Aniruddh and Tony, guys. So we'll take a break for around 10 minutes and we'll get back. Aniruddh, you want to just give a quick preview of what we'll be covering in our next session?
Yeah, so the next session we will talk about design, UI design for Android, and we're going to share with you some tips on how to create tablets apps, and also guidelines on things like how to use action bar and things like that. So how to make really an Android style application. So stay tuned.
Okay, fine. So we'll take a break for around 10 minutes and we'll log in back. Thank you.
Cool. See you guys.
Well, ladies and gentlemen, you're going to have some water, you can have it. The water stations are extreme corner of track 1. But we're not going to delay it. Exactly on dot 10 minutes, we're going to start the session. We're going to resume the session where we stopped right here in just a bit. Thank you.
We'll just give him a call or text him. Meanwhile, if you have any kind of questions during the entire session, please do write it down because we'll be moderating it. And only the difficult questions, if they are really, otherwise most of the information is pretty much available on the net, right? So if you got really something which is not there, let's utilize their time pretty effectively. Yeah. Aniruddh, welcome back. So let's start with our next session. Over to you guys.
Thank you. And welcome back. And so the second session, let me share my screen first. So the second session is about definitive Android design. And so the first topic we're talking about, we want to talk about style. So as you know, in Android there are many different form factors of devices and or even type of device. Sometimes it could be tricky to design layouts and to accommodate all these like different form factors. So the idea is to create a layout that is flexible, and also you really want to optimize your layout as well. I mean, and what we mean by that is for small form factors, you may want to design one special layout for it, and for larger form factors, you may want to design a completely different layout to leverage and take advantage of the real estate, the extra space in those devices. And we will talk about fragments later, and Aniruddh will talk about different kind of strategy you can use later on in the sessions. And finally, for assets, what we mean here is the graphics you use and should also be optimized for different form factors. Like the Android framework is kind of smart because it will rescale images for you, but at the same time we are talking about additional like CPU, GPU time and also like spending extra battery. So it's really important you have access actually dedicated for different form factor. So one very important topic we want to talk about is something called density independent pixel. In fact, it's so important. We actually had a hangout office hour, the ADL Plus office hour last week. We have a special presentation just dedicated to this particular topic. Feel free to check it out if you want to learn deeper into that topic. But right now I'm going to define what DP is and go through some of the stuff. So DP is really a virtual pixel for defining a physical length in your design. It's really a physical length, just like centimeter or millimeter. And the definition of 1 dp at the medium DPI, which is 160 DPI, is equivalent to 1 pixel. So this is the equation to do the conversion between a pixel and DP and the relationship between the two things. When you design your layout using DP, it allows you to build like really flexible UI regardless of the resolution of the screen. So to further illustrate that what we mean by resolution independent, below there are four rectangles which kind of represent devices of the same physical size but in different resolution. So we have LDPI, MDPI, high DPI and extra high DPI. So you can treat like one of these like little square inside the rectangle as a pixel. So if you have a medium DPI device, which is the second rectangle, the number of DP we are talking about in this case is 4 DP. And the reason is, as I mentioned before, we are treating one of the small square as a pixel, right? And by definition of DP at the media at MDPI, 1 pixel is equivalent to 1 DP. So in other words, since we have 4 pixels in this MDPI rectangle here, and therefore we have 4 DP for each side. The interesting thing about these rectangle is once we find out the DP of each side of the rectangle, all 4 rectangles actually have the same DP. So regardless of high DPI or LDPI, each side of these rectangle is measured as like 4 DP. So that's the beauty of using DP in your layout, because it doesn't matter anymore. You have like 10 different devices, 7-inch devices, for example, but having different resolution, because as long as you define your layout in DP, it really doesn't matter how these devices resolution varies, because the physical size of the layout you define in your layout XML is going to work regardless of the resolution. I also mentioned this a little bit earlier before in the previous session, how to pick the right qualifier to select tablets, and in particular for 7-inch tablets, the smallest with 600 dp is the magic number to identify the 7-inch device. but unfortunately for Android 3.2 or below, the new qualifier doesn't exist. So you still need to use the old qualifier, large, extra large, to help to select the right layout to use for the pre 3.2 Android devices. So you should use combination of these resource folder in your application to classify which layout to use in your application. Designing an application on touchscreen is really tricky, and our UX team at Google actually have done a lot of research on this, and the research shows for touchscreen object, the acceptable height of these items should be between between 7 to 10 millimeters, and so we kind of picked something in between, which is around 9 millimeters, and that's how we come up the 48 dp as a recommendation of what's the minimum height of a particular item in Android that developers should create for items in order to make user feel comfortable using the touch screen. Also, in addition to the 48 dp recommendation, we always want to leave some space or padding in your design. For example, between buttons and icons, there are 8 dp separating the two controls, and also a 4 dp above or below the button before the next item in the list view, for example. So here another example of our kind of guideline, what kind of spacing padding we recommend. One thing I want to draw your attention in particular is there's a 16 dp vertical padding on each side of the screen, and why we want to have a padding like that on the screen in general. Turns out the answer is when you hold your phone with your hand, it's very easy to have some of your fingers or your palm actually touching the edges of your phone. And if you design your application with event listener actually listening to these to the edge, you will get a lot of these false positive events, and that actually create bad user experience. And that's why we recommend developer to have these 16 dp kind of padding on each side of your screen to avoid these kind of bad events. Some more best practice to share with you. The first one is use web content, few parents, and also always use DP units in your XML layout files. Do not hard code pixel value in your code, because it's not going to work and it's not going to scale nicely in device of different resolutions. And there should be absolutely no situation you need to use the absolute layout anymore. It's totally deprecated, and just stay away from it. Finally, make sure you create specific bitmaps, drawable access for different kind of device. As I mentioned before, the framework is going to will be smart enough to scale images accordingly, but you want to avoid these unnecessary computation which will eat up the user's Android's battery. So one thing I want to point out is the TV DPI. As it it's really for TV, as well as one interesting thing is the Nexus 7 is also having that TV DPI as well. So pay attention if you are writing application targeting the Nexus 7. The next topic I want to talk about is Action Bar. And so Action Bar is really start to become very prominent in Honeycomb, and it's really a pattern we recommend, and you can find Action Bar across like different kinds of Google applications, and you can think of and using. And one thing about in the past for menus, option menus in prior to we introduce introduction of Action Bar, we find it very difficult. Users use the option menus like very rarely. So and we hear feedback from developer. A lot of the features kind of not surface enough, and a lot of functionality was not actually used by the user. End up if they are put inside the option menu. So one thing we try to fix through the Action Bar is to make these like options item more prominent and display it to the user on top of the screen, and that's another kind of motivation of using the Action Bar. So Action Bar has 4 major components. So the first one is the app icon, so which is your brand, and also the way how user navigate within your application. So so there is a back concept and a up navigation concept, which actually kind of we won't have time to cover those in detail today, but I encourage you guys to look at our design guideline to find out more about what the up navigation really means, because it's different from back. The up navigation is really traveling up the hierarchy of your application's tree structure. And the back button, the back navigation is really, you can go from one application to another, or even back to the home screen. So there is quite a bit of distinction between the up navigation and back navigation. The second component of an Action Bar is the view control. It's really a spinner, serve multiple purpose. So if your application have different accounts, or allow user to switch accounts, so that would be the place to go. Another use of the view control is to, if you are serving information in different categories, or if you have contents of many categories, so that's also the place to allow user to go to drill down to a particular category. The third thing, as I mentioned before, is really what we call action buttons now, but what used to be called the option menus. So all the older applications which have option menu defines is now going to show up as action buttons in the Action Bar. But as you can see in the screenshot here, the Action Bar, the space on the Action Bar is kind of quite limited as well, especially in the portrait mode for in the phone. So what we do is we introduce something called Action Overflow button, which is the 4th component, to allow additional menu item hidden in this overflow menu. So here are some example. Is our Gmail application using the action bar. As you can see from the screen, the action bar will render intelligently based on the device form factor and the space available. On the phone screen, you can look. The action buttons are actually at the bottom. So we have something an attribute allows you to customize that to show all the action buttons at the bottom of the screen, and if you rotate the phone into the landscape mode, which allows the action bar to have more space on top, so you can see the action items now goes back to the top. And for tablets, again, we have a lot of space there, so and it will display even more buttons in the tablets in the tablet screen. There's another kind of like special configuration you can do in action bar, what we call stack action bar. So if you YouTube is one of the example we are using the stack action bar. So what that means is, like, if you define action bar to use the stack feature, the view control area will actually goes to the second row of the action bar area. So here's an example how YouTube looks like when in portrait mode. And the view control or the tabs is actually wrapping into the second row instead of occupy the same row as the action bar. Earlier we also showed you the split action bar, and so to have all the action buttons actually display at the bottom of the screen. And so if you have an action bar, all you need to do is to add an attribute called UI options split action bar when narrow. So this will tell the framework to render the action buttons at the bottom if they're not in the spaces. So one thing about action buttons are there could be more than just a few of them, right? And we already introduced the overflow menu, but now the tough question is, how do we decide what action button should display more prominently instead of hiding them in the overflow menu? So we have some recommendation or a scheme, I would say, to allow developer to make the decision. So we have something called the fit scheme. So one thing you really want to know, ask yourself is, how frequent is that particular action is the user going to do? Is it going to be more than 70% of the time? Is it going to repeat a lot of times? Like, those are the actions that you should consider put on the action bar, showing up like permanently. Another consideration criteria would be, is those actions really important in your application? And the last things you want to ask yourselves also is, how typical is that particular action show up in your competitors' like application or similar application in your category. So one thing is, like, for example, the search action is really typical in most of the application, right? And that would be something probably a good idea to put that action on the action bar permanently. Things like you only show it once or twice, like the terms of service or about us, like those kind of action would be a good candidate to put in the overflow menu. So in terms of the overflow menu, we have actually something special for legacy purpose as well, because like we understand not all applications are brought up to speed to use the latest technology, the action bar, which by the way you should, because otherwise your application, if there are option menus and in new phones without physical buttons, in the system bar we will show a special icon with 3 vertical dots to indicate the availability of option menus. So this is really for better compatibility. And so one thing about this is kind of really a strong indicator for user or even for our featuring team to as a signal to see this is really a legacy app. So it's really a bad thing. We really encourage developer to upgrade the application to use action bar, use the latest features in the framework. So this will kind of showing the legacy icon is a bad signal to the user and also to in Google Play as well. Another element in the action bar, we understand sharing. A lot of applications now have the share feature, and we want to make it really easy for developer to incorporate the share capability, and that's why we introduced in ICS something called Share Action Provider. So this is really simple. You can specify this share action provider in your menu.xml, and then it will be available as a menu item in your action bar, especially in the contextual action bar. The widget is very nicely done, and it will you need to specify the intent, the kind of intent your application can consume, and it will automatically populate all the application that can consume the intent you are sharing. And one last thing nice about this widgets is it will show the most popular used application of for that particular user. So in this case, for example, like the Gmail icon is the default share application, because that's the application for this mostly used by this developer, this user when he or she try to share things. Some guidelines about icons. So we have extensive guidelines on different icons used these days in our Android design guideline website. So in particular for action bar icons, we recommend the size would be 32 by 32 dp, and as I mentioned before, we always want to leave some padding. So the effective size of the icons is really 24 by 24 dp. In terms of style, we want the icon to be flat and not with too much detail. So one thing, if the icon is kind of narrow, thin, just like the pencil icon in the example there, we suggest to rotate those icons 45 degrees. And finally, for action bar icons, they should all be grayscale. Shouldn't be they shouldn't use any color for action bar icons. So the third topic I want to talk about is notifications. So we mentioned a little bit about notification, rich notification in our first session, and I would like to go a little bit deeper in terms of design of notification here. As I said, like the regular notifications just stay the same. So we have so this is the kind of the base layout of a notification. You always have the icon photo on the left with the title bar on top with a timestamp. And then you have a message under the title with a secondary icon on the right. So nothing much change in Jelly Bean for the base layout. We just add a new layout for what we call expanded layout. So user can transition from the base layout to the expanded layout through different gestures. So they can either do a pinch zoom or do a two-finger glide to toggle between the two layouts. So as I mentioned before, now actions in notification are now part of the framework. So they are used to handle most like common tasks like without even going to the application, and that's the beauty of actions. So notifications, the idea of having notification is to make the user life easier. And sometimes like that means it's not even the need to go to a different to your particular application. So you want user to have a good experience and can be very productive with the Android device, and by making like good notification will help to contribute to that. So a couple of things to keep in mind is to not abuse the notifications. So some good actions would be like to help to decide what kind of action is good for notification is you can use the same like fit scheme which I mentioned earlier. And also actions on notifications are most of the time time critical, like an alarm or a calendar event or someone pinging you from chat that requires the user immediate attention. Some of the bad actions would be like something really complex. You don't want user to do like very complex tasks within the notification. Another bad example would be, so most of the, by clicking on a notification, usually just open up your application, right? So that's really a standard action, right? And you don't, just make sure don't create action that will repeat these like kind of default action. So there are different ways user interact with your with the notification, and so here are some examples. And there's one special type of notification called ongoing notifications, which is like when you are playing music or you have a service actually running. So user, for those notification, user cannot dismiss, and but do pay attention, like when you choose to use this kind of notification, because if you don't pick the right kind of, if you don't choose like it appropriately, you will annoy your user, and turns out user will uninstall your application. Another thing I want to mention about notification is some of the feedback things like it meant to be done using other UI, for example, like dialogues and or even a tools in the Android system. So those things are not meant to be to make it as a notification. So make sure you choose the right UI for the right purpose. So when to use notification? So one key thing is notification should not be intrusive. So that's really the top things you want to keep in mind. And you also want to inform your user on time-sensitive things. And usually notification is coming from another person. So time-sensitive and personal are the key. So, but when not to use notification? So turns out there are many situations you shouldn't use notification. So for example, stuff that not directly related to the user, the opposite of time sensitive, and if the user is already on your application, don't show notification when the user is already using your application. Stuff like really technical, low level, you shouldn't expose it to your user, and for recoverable errors, don't use notification for those. Also, using notification for showing your brand probably is not a good idea because that doesn't contribute much to the user. So these are the things like you should not use a notification. Some guidelines for designing notification. Again, personal is key. And when the user click on your notification, make sure you guide them to the right place in your application. So I'll give you an example, like when you hit the hit the Gmail button, a Gmail notification should point directly to if you only have one email in the notification, you should go to the email itself. But if you have multiple emails, you go to the inbox, like things like that. So the destination has to be modified correctly. And finally, you should clean up your notification intelligently. So what that means is, like, I'll give you an example. For calendar notification, if an event is already has been passed, is a past event, it's probably a good idea to just get rid of the notification from the notification tray for the user, because it's not going to be relevant to the user anymore. In the first talk, we talked about notification priority. So this is something we introduced in Jelly Bean, and so we have 5 different category of priority. So the maximum priority is for something like incoming, outgoing calls or navigation turn by turn. High priority would be something like receiving email or real-time chat, things like that. Default is like for anything that is currently used for notification. And for low to minimum priority would be something like kind of only informative to the user, but not super critical things. I guess you may have the questions like, oh, okay, so wouldn't it be the best, like, if I set every single of my notification to maximum priority, so I will always like occupy the top spot of the notification tray? Really tempting, right? But please don't do that. So one thing, as I mentioned before, user have complete control now to enable, disable an application notification completely. So the last thing you want user to do is to disable your notification entirely. But what's worse than that is like you are risking to have your user to uninstall your application, which is the worst thing so make sure you become a good citizen in the Android framework and use notification appropriately. Is actually to your benefit. Another guideline for notification stacking. So if you have multiple notification, the bad thing to do is actually showing multiple notification from the same application. So instead, what you should do is to stack them together and add a number pending right next to the secondary icon, showing to the user actually they have multiple notification from your application. So the peaking feature on top of the notification, the status bar is actually one place very useful for. Make sure you take advantage of that. So it just happened like a few seconds, but it's really informative to user on certain events. So make sure you take advantage of using that. In terms of icon guidelines, the size of the icon is 24 by 24 dp, and of course, like we want to reserve some padding. So one dp per side. So the effective size of the notification icon is 22 by 22 dp. In terms of style, it's just flat and simple. Very simple visual metaphor for your application. And color is very important. It's only white. So I saw many applications actually using color notification icon, and that doesn't conform to our design guidelines. So you're lowering your chance of getting being considered to be featured. So the next topic, Aniruddh is going to talk to you about multi-pane layouts. Aniruddh.
Yeah, thanks, Tony. So as we started, as the Android ecosystem and the hardware started diversifying, we started seeing many tablets being released and different form factors, 7-inch, 10-inch. And so what we realized very quickly before we launched Honeycomb, which was the tablet specific OS, was that there's a lot more real estate available in some of the layouts. And so what we decided is to introduce something called fragments. And fragments is something that can enable you to create multi-pane layouts. So you can have different sections in the screen dedicated to different UI modules or functionality. And fragments have their own life cycle, and they can actually be embedded in different activity as in when you want. We'll look at some of fragments in detail. But if you just see the screenshot there, you see this combining multiple views achieved using fragment. You see there are two panes here. On the left side is there are actually three here, because it's a tablet and we have much more real estate available to us. So on the left side you see a contact list, and this is a list fragment. On the center section you see a detail fragment which has the contact details, and on the third section you see social updates from the user. Now this is a tablet. On a phone what you would do is just display the first two fragments, and then you can create another activity with the third fragment. So if you see the example here, there is one activity just hosting the list fragment, and then you move on to another activity. Or you could remove the fragment and replace it with the detail fragment. You could choose either of those options. Is that when you click on a contact, you get the details, and the details pop up. By reusing these same fragments, you're able to create different UIs for tablets as well as phones. So when we talk about having fragments, and we have different UI configurations like phone and like rotation, and these create different orientations and configurations. So what are the strategies that are available to organize these fragments? So the first one that you see is stretch and compress. Now you're looking at the settings list on the left side and the setting item details on the right side. As you see, when we rotate the device, one strategy you can use in your app is to just reduce the size, which is stretch one of the fragments and compress the other one. So if you see, the device goes from landscape here to portrait. The real estate is now more horizontally available, so we kind of stretch the detail of the list view of the settings, and then we kind of compress the number of items actually that you can see, and this is one of the strategies. The other strategy that you should consider when you're writing your application, and the thing is, many apps and many developers do not consider these, and the reason we are having this talk is we want to share with you the best strategies that you should use so that you can create these fluid UIs which users love, and that means more successful apps. So looking at this, is the second strategy is the stacking strategy. Now this is a calendar, and you see a weekly view on top, and you have all the calendar entries, and then on the bottom you can see a mini widget kind of fragment, which is actually the date picker or the week picker. And as we rotate, instead of stacking them vertically, we stack them horizontally. So stack is another strategy that you can use to organize different fragments. And this is very simple. You really don't have to code much. You just provide the right layout in the configuration. So in the resource system, so on layout horizontal on landscape, what you do is you provide a fragment with another fragment inside a linear layout with orientation set as horizontal, and with just one property change is horizontal and vertical orientation of the linear layout, you can place these two different files in different folders, and that's how your application will behave. And you might have to take care of some asset sizes, but really minimal coding, the resource system is great to enable all this stuff. Right, the third strategy we can see is expand and collapse. So Google Talk uses this strategy, is what is, if you change the orientation of the system, you can completely collapse a fragment and expand the other one, and on the same thing on the phone, that you can kind of collapse the chat list of contacts, and then you can show more area of the chat detail which is going on. So this is another strategy. And the final one is show and hide, which is something you can see in Gmail. And it's kind of where it makes sense on what to use. So in Gmail, when you're actually composing an email, writing an email, you need some space to write the email. You wouldn't want to write a complete email in a small text box on the screen. So what we do in Gmail is, when you go into compose and you go into landscape orientation, we completely hide the list of emails fragment. This email, so that you have a richer experience when typing the email. Of course, when it's horizontal, you have enough space already available in terms of width, so we have the fragment visible. So look at your app, consider what your app is doing at that point, and choose the right strategy to either stretch, collapse, or show, hide, or stack different fragments together, and give the user the experience from the screen that you want for the user. So also in terms of backward compatibility, we have virtual navigation controls that are available. So if you see, there is action overflow menu there on the top, which can give you, you can quickly switch to different modules of the application. Some of the older devices had a physical navigation key, and even some of the new ones do have. So when the physical key is available, we use that to trigger the action overflow or the action items of the menu. But in case your app does not have a hardware phone, we use the virtual. And if you want to take advantage of this, you just have to maintain backward compatibility, is that you set your target version of your SDK to 14 or ahead and do a quick test, and we will enable backward compatibility for your application, giving you newer UI or newer UI cues like virtual navigation controls for your app. So here is an example of how it's happening, that you can see we have this little menu on the bottom bar, and you see the 3 dots there, and that is being used in the to trigger the menu button overflow. And this will happen if you you set the right target SDK version for us.
Yeah, and what you should do as a developer is really upgrading your application to use the action bar instead of showing the legacy button.
If you want to take a look at the new action bar patterns and how you can actually use the action bar, which is part of the SDK framework starting Honeycomb, but it's not available outside that. We have a sample in SDK, that's the action bar compat. And this is not a full sample, it's not a full code base, you still would have to do some work, but you can look at draw inspiration of some of the things that have been done to actually enable action bar on pre-Honeycomb devices. It's a very thin wrapper in the sense that it provides an implementation for anything less than API 10. But if you are on API 10 grader, you can use a system implementation. There are also some very popular action bar open source frameworks that you can use, and action bar Sherlock is one of them. It's pretty great actually. You can also consider using action bar Sherlock in your application. So let's recap quickly at fragments and when you should use them. Completely, they are reusable UI components. They can have their own views, and they can completely be used across activities, can be used in multiple activities, and multiple fragments can be used in the same activity. And you can also organize your layouts in sections, and so your code becomes more modular. And you can embed these fragments in any activity to provide a quick way for the user to take an action. Depending on your device configuration and using some of the filters that Tony talked about in the previous session, is the smallest width. You can choose to display 2 fragments, or you can choose to display a single fragment and just move across screen to display the next fragment. And what it really does is it helps you create a single app, one APK that you can target for both phones and tablets and any kind of devices like a Galaxy Note with 5-inch, and you can specify your layouts and use your fragments to use your code base. And the good thing is that fragments are completely backported, and so if you are running anything from Eclair onwards, you can use our support library, which has a full implementation of fragments, and you can provide fragments to users on your older phones using your app. And some of the more features available in swipeable in our support library is something called a viewer pager class. This actually helps you swipe across screens. So if you've been using newer phones, you would have seen this pattern used a lot, that you do a finger swipe and you can change the fragments. In this case, the fragment is associated with a tab, and as you swipe, we change the tab value and you get the next tab selected. This is the adapter behind which holds the fragment is called the pager adapter, and the class that is containing the UI layouts is the view pager. And so this is something available with support library that you can immediately apply in your projects and enhance the look and feel of your applications, as well as create more modulable and reusable code. So we discussed about fragments and the view pager readapters. There is something else called the loaders, and these are very nice components that help you asynchronously load data in your application using cursors behind the scenes. And it has some couple of callbacks that you can implement. So on data complete, or when the UI wants to refresh the data, there are some callbacks there, so you swap the cursors. But we recommend using loaders for you. Please do not directly work with cursors. These loaders will manage the life cycle of a cursor and help you with asynchronous behavior. And it's very easy to add the support library to your project. In Eclipse, you can just right click on a project and go to Android tools, and in the screenshot you see there's a small icon saying app compatibility library, and you do that and it's already included in your classbar, and you can start taking advantage of it starting 1.6 onwards. So also we need you to have those grayscale icons without background, and this is what you should be using. These are easily and readily available. There is no reason for you to ship your iPhone icons in the phone. And also the usage of bottom bars, bottom tab bars, as you can see in the screenshots, is what we recommend. And we the one of the worst things that developers have been doing from iPhone is just carrying over this labeled back button that you see on top of the gallery there. In Android, we have a dedicated hardware slash soft button for this in the bottom bar. It's one of the main pieces of navigation for the user, and they are so accustomed to using that back button that when you do not provide that and instead you provide a button on the top, it's kind of annoying for the users. So do not use navigation means that are not meant for the system. There's a back button available which is completely tied up into the backstack of the activity framework. Please use that instead. Again, not use right point caret buttons like you see in the iPhone settings screenshot that we have here. This is not how Android looks or feels or wants to do stuff. So yes, avoid these. These are the list of do's. Do not have bottom tab bars and carets. And Tony had a detailed this before. The use of action bar is highly recommended. There are a lot of apps which use action bar. And we highly recommend that unless you're a very exceptional app, for example, a game or something different, please go for an action bar. We have a lot of framework components to help you enable it. Then there is, look, Android has very great location providers and services in terms of course location and find location. So you can actually make your app smarter by building these context-aware apps. For example, if you have a restaurant directory app, you can take the advantage of users' location and find out something that's close by and tell them. So use these features that are available to you rather than to be smart with your app. Something we also recommend is preload data at appropriate times, which is that prefetch the data. Do not we have great sync framework that can help you preload data so you can sync beforehand. We do not want the users to open up your app and see a loading dialog where you're trying to fetch the data. There are framework components which you can use, like the sync provider and the async content providers, where you can preload all this data, and when the user opens the app is ready with the data, it's fresh and it's snappy. For example, in the calendar app, we could reload the agenda for a couple of days and just store it in the SQLite storage or wherever you prefer. And when the user opens the calendar app, he already has the entries with the stuff ready. At this point, you should not be loading data. And creating something is fine, but also with innovation is good. But you have to really focus on UI experience for the user. Android users are very smart these days, and they like to, when they buy an Android phone, they like to see the stuff, the rich notifications, the stacked widgets, the home screen widgets, the live wallpapers, and that kind of stuff in your app. So focus on the user experience a bit more. Use the system themes, and if you have your own theme, blend it with the system look and feel so that you provide a user with a UI that actually blends with the rest of the operating system and the system apps. So do spend some time creating the right assets for the layouts for different form factors, and make it fluid, make it nice. The other thing is, again, I talked this about with preloading of data, that we have great framework available for you to get data. So once you have data, you've preloaded the data, you can actually enable it to provide offline support. For example, in the Gmail app already preloads, stores your email with you on the phone. So when you use the Gmail app, you don't have to be necessarily connected every time. You can actually use the offline support of the app to show data from the database. And this database is being regularly synced with batch network operations, and most apps are synced, and the component there is sync service. Use that sync service to keep data, bring data offline, and use your UI to fetch the data offline, which is to fetch from these content providers and not directly hit the internet services. So that pretty much wraps up our presentation. Again, we've got some important links there. The first one is developer.android.com/design. This site is completely dedicated to UI experience, what fonts you should use, what colors, what are the patterns. Most of the things are discussed there. So please go ahead and take a look at the website. And we are open for questions.
Unfortunately, Aniruddh, there are more than around 50 questions, but we are completely running out of time. So we thought earlier on that we'll be able to take questions, but I think you can once again let them know what's the best way to get in touch with them. I've collected all the questions. I can post it on G+, or is there any other better way to solve all this?
We have our weekly hangout show. I suppose we don't have tomorrow, which is a regular timing.
Yeah, tomorrow we don't have one, but probably the week after. Yeah,
So-
and also I think if you guys have questions, post it in G+, either directly to us or in Android Developer Plus page. That will work too.
There are 3 office hours happening in all timings. You can actually go to the moderator link for any of those and post your questions, and they'll be answered right there live. And you can send them to us. My Plus page is plus Aniruddh Devani. You can send questions over to me or to Plus Android developers or Tony there.
Yeah, mine is plus Tony 10 CHAN. So
Anytime.
Okay, fine. So thanks a lot. Once again, I apologize. There are a lot of very good questions. There are a lot of questions from Deepa, and she has sent me almost around 8 or 9. So, yeah, everyone has got tons of questions too. I think what's very important now is we are all starving and it's lunchtime. So, thanks once again, Aniruddh and Tony. Huge round of applause for them. Thanks for taking time out. It was really wonderful.